Welcome. So as we're waiting for just a couple people to roll in, so Jeremy Renshaw just gave us a nice review of sort of what the EPRI grant challenges are about and what we're trying to address with them. So these span a bunch of different areas of energy and AI. And the focus of this breakout session is going to be on environmental impacts, which is a broad topic. So I thought I'd go a little bit into setting the stage for what that really means. So the agenda, we're going to have two speakers, Becca Madsen from EPRI and Isa Shea from SAS, are both going to give us a presentation on what they and the organizations have been up to in the space of AI for environmental impacts. And then we're going to have a panel of exciting speakers that span AI and electric power, including Xin Jin from the National Renewable Energy Laboratory, Lena Rold from the University of Wisconsin-Madison, Arun Vishwana from IBM Research, and Marcus Voss from Climate Change AI. So we encourage you as participants during the panel session to ask questions via the chat, or if you want to raise your hand, I can unmute you and you can ask the question to the panelists directly. And then we're going to wrap up and talk about next steps at around 5:15 Eastern. So thank you again for joining. And so what is environmental impacts? And first of all, who am I as well? So the mission of this session is to utilize AI to rapidly reduce carbon emissions. I think this just switched. There we go. To rapidly reduce carbon emissions while tackling some of the most pressing environmental impacts. So this is sort of moving beyond just taking a look at, resiliency or smart cities, but also taking a look at how this is impacting the environment and the world we live in. I'm your facilitator, Kyrie Baker. I run the Griffin Lab at the University of Colorado Boulder, and we focus on these exact issues, how we can use AI and optimization to make the energy system have a sustainable and equitable transition to a zero carbon economy. So I studied electrical engineering from Carnegie Mellon University for all my degrees. I was at NREL for 3 years, and I just received an NSF Career Award on this exact topic, using AI to operate power grids. So it's probably not a surprise to many of you that greenhouse gas emissions have been increasing. Across the right-hand figure is carbon emissions from fossil fuels to 2014, and you can kind of extrapolate that towards 2020 globally. The left-hand side is just looking at the US. So transportation has now surpassed electricity generation, which is why we're having a big push towards electrifying transportation. We also have other sectors that pose a significant amount of contribution towards greenhouse gas emissions in the US. So how can AI help? So we heard from previous speakers this morning about improvements in computing. We didn't have the same computing technology that we did a decade ago. And so that's why we're seeing a big boom in AI and ML related technologies. CPUs and GPUs both are increasing in economic feasibility, although recently that's been a little bit more expensive, but generally trending towards cheaper, being able to perform more floating point operations per second, and being more accessible to a wide range of researchers and people from industry. So how can AI help? So here on the right-hand side, in Colorado here, we had really bad wildfires last fall. And this was a distribution feeder that's serviced by basically one big transmission line. And the wildfires were threatening that community's access to reliable power during October. So you can see just how close the wildfire reach was to this community. That's a distribution feeder. Every node on there is an individual house. So when we're taking a look at, maybe operating the grid in more intelligent ways, we also need to take a look at how that interacts with the environment, how it interacts with natural disasters, extreme weather, and how we can ultimately benefit humans using AI. This picture on the right-hand side is from my backyard. You can see the power lines are actually touching trees. If you're familiar with you know, the 2018 Camp Fire in California that was caused by a failing transmission hook that fell, sparked against a power pole, and caused one of the most expensive and deadliest wildfires in California history. We're getting a lot of power failures that are having to do with failing infrastructure. So how can AI assess this automatically and help us do things like vegetation mitigation, help us winterize different types of infrastructure, help us determine where to make those upgrades? We also need to look at different types of sectors that interact with electricity. So if you weren't aware, thermoelectric power plants in the US are responsible for, I think, 40% of freshwater withdrawals. So power plants need a lot of water to cool, a lot of water to turn into steam, to turn the turbine to generate electricity. We can use AI to do things like monitor power plant water discharge temperatures to make sure it's not harming fish and other wildlife from having temperatures that are too high. We can assist companies to track and fulfill sustainability commitments. So a lot of these things that would be really challenging to do manually, we can use data and computing to facilitate these. And here's a map of just looking at the US states that have put different types of renewable energy or greenhouse gas emission goals. So you can see that, and I wouldn't be surprised if, you know, a year from now, there's even more colored states in on this map. A lot of states, in addition to federal goals, are putting forth their own either executive orders or legislations that are trying to push towards decarbonization. So this is done in both the electricity sector and transportation and in the building sector. But we want to use the technologies that we have, everything, including big data, AI, machine learning, and conventional technologies, as well as operator insight and know-how to make these goals happen and hopefully even get faster and more expedited years of adoption. So let's all get together and bring these applications of AI into energy and make it become a reality. So as an academic, you know, we publish papers all the time. We talk about these lofty goals, but what our ultimate goal is to actually put those into real systems. And so that link is right now a little bit weaker than it could be. So what we're going to do in this grand challenge session is we're going to talk about goals and success criteria. You're going to hear from some experts in the area, determine actionable next steps. What can we do as a group to make some of these challenges, to make some of these goals a reality? And we're going to identify representatives and experts from both the energy sector and AI that can help us solve that challenge. And before we go to our first speaker, I leave you with a very, very bad pun, which is don't miss the forest for the trees. So we need to take a look at the big picture and not get caught up in, you know, a lot of the details, because we need to be reminded that we're ultimately working towards the large goal of decarbonization. This requires an ensemble, not to use another pun, of people passionate about decarbonization. So we need AI researchers, we need people who are experts in the power grid, we need policymakers, we need researchers, we need everybody. I look forward to your participation and perspectives on this. And again, please feel free to use the chat to ask questions to the participants. And let me stop sharing. All right, so our first speaker is Becca Madsen. Do you want to try to see if you can share your screen?
Sure, I'll do that. Yeah. Here. So, did you have a segue or should I just jump right in?
No, jump right in. And would you prefer if people waited till the end to ask you questions, or they could just type it in the chat as we go?
You can type it in the chat, and Kyrie, I give you full power to stop me and interrupt, because sometimes I don't notice those chats coming through. But otherwise, I'll kind of flow through. So hello everyone, my name is Becca Madsen. I'm sort of the EPRI representative on this panel here. I'm a senior technical leader and have been around for about 8 years. And what I wanted to do is just to give you a little bit of foundation of the electric power industry and where some of those environmental interactions are, in addition to climate change and and carbon and things like that. A little bit broader spectrum. So I'm going to move through here. So just a couple slides just to show you the breadth of where power is being made, and there's the various types here, along with where transmission lines deliver the power from where it's generated to homes, basically. So from transmission to then going to distribution. And a little graphic here just to show you some spots of where some of those interactions might come into play, along with our bulleted list of environmental research that we do at EPRI to address these different kinds of challenges. So you might be thinking about climate change and carbon. You might think about air emissions when you think about power generation. But there's also impacts to species habitat, avian species, and transmission lines, along with wind generation, aquatic species. We think about aquatic species protection in terms of the water intakes for cooling water at power plants, along with, you might come to mind, fish ladders to help migrating fish get over hydropower dams. So there's a lot of different places where environmental issues intersect with the generation and delivery of electric power. So get you thinking about that. So why have we been thinking about artificial intelligence and its place in this world of environmental issues? Really, we're just trying to meet our mission at EPRI to provide research that helps provide safe, reliable, affordable, and environmentally responsible electricity. So AI is a component in that, and largely driven by new data sets. Here we go. Yep. New data sets like Earth observation imagery that have come from traditional satellites, from our space administrations like NASA and the European Space Administration, along with newer cube satellites that can take observation imagery the size of the country of Mexico in one day, and there's about 300 of them in the atmosphere right now, maybe more. I haven't checked lately. So these, along with other data collection platforms like drones, like video cameras, with computer vision, water drones. In the middle, at the bottom, there is some swarming underwater drones. They're pretty fascinating to look at. They look like a school of fish. Audio collection, data sensors to listen to and collect information about bats that we can't hear, and then sonar collection. And another data source is lots and lots of textual data, something that maybe we don't often think about. But all of these are creating these very large data sets that allow us the opportunity to apply artificial intelligence and data science. So we have been seeing the investigation and actual application of AI and other forms of data science to lots of different issues in the electric power world, but we hadn't really been seeing it with regards to environmental issues, or at least not in an aggregated sense. So we started an initiative a couple years ago to investigate where are there applications of AI and other data science to environmental issues that are relevant to the electric power sector. All of the research that we've done in this initiative is available for free on epri.com/envdatasci that you see at the bottom of the screen there. And we're not just looking at AI as a fancy new tool, but we're looking at how does that align with the mission of reducing costs and keeping electric power affordable, reducing labor, reducing regulatory risk, and basically impacts to the environment. So some of the research that we've done has looked in a broad way at the literature and said, for all these different research areas that we cover, air quality, water quality, sustainability, safety, endangered and protected species, where are there applications of AI in the literature? And so we have a literature review in two parts here that, again, are available on that website. And it's a really nice synthesis to kind of show you, for any one subject area, where has there been research that incorporates AI? And oftentimes there's also very large data sets that are going into that as well. So it's a nice little synthesis if you want to get a little flavor of what's going on. Some of the examples that we're seeing, I have in this bottom list in the literature, and some of the projects that we at EPRI have been working on, I have in the top bulleted list. And so I'm going to go into the two examples that are starred there, and I'm just being mindful of time, so I'm going to make sure. I forgot to set my timer earlier, but I'll set it now. So I'll go through two different case studies, and then we can pause, and if we have extra time, we can do an audience choice and take a look at this list again and see if you have any questions. So the first example, I'm going to move to my, I'm going to move over here. The first example is applying deep learning to identify wetlands. And if you'll bear with me, this is a Esri story map. So it's kind of a standalone communications. And I'll give you the link when I'm done so you can view this and read more details. So I'm just going to sort of go through it rather quickly here. But the reason that we're interested in wetlands and identifying wetlands is that under the Clean Water Act, every infrastructure project, every project in general, has to avoid, minimize, and then compensate for impacts to wetlands. And so in this little swipe tool here, you can see that there is a line of wind turbines and access roads that are going to them. So normally you would see this going in a relatively straight line, and you can see that there's some avoidance of wetlands that's happening in blue. So the data that we rely on to try to avoid and minimize wetlands is called the National Wetlands Inventory, and it's known to have errors of omission and commission. So our members, who are electric power company advisors, have told us that they're interested in what is the cutting edge of desktop wetland identification so they can do a better job in the early planning phases of avoiding that. So we've gone into some research, we've reached out to them and asked them what kind of aspects they would like to see in a tool or model to identify wetlands. And we started collaborating with the Chesapeake Conservancy's Conservation Innovation Center, who suggested a method of using UNet, a form of deep learning that provides greater accuracy over other methods of machine learning. So to input the model, of course, usually you need training data and lots of it, which we thought we had from our member companies who said, yes, we have hundreds, we have thousands of field delineated wetlands, polygon GIS data, right? Unfortunately, as you can see in this sort of example here, the wetlands were arbitrarily straight lines, which is not how they occur in the real world. But of course, if you're sending out a consultant into the field, there's no need to go beyond the project boundaries. So we couldn't use this data because if you tell a machine that wetlands have straight lines, it will spit back wetlands with straight lines. So we needed to get better training data, and we found some high quality training data, publicly available training data from these three areas, and I'm not going to go into detail. But this training data, along with satellite data, imagery is not coming up right, but this is actually geomorphon data, which is a derivative of LiDAR data, along with satellite data were other inputs model, and you can read more about this or ask me about this later as well. So the AI model performance, and again, this is UNet, a form of deep learning, was very good, and we were very happy with the results of that. But what it actually looks like is this is kind of zoomed in, and you have this, here's our standard data layer that we have, National Wetlands Inventory. A straight line over here happens to be a transmission line, same over here. And in pink is the model output results. So you can start to see the differences with the standard data and the AI-enabled deep learning model. So that was one example, and I'm going to pause for a second, this up, and go back here. So my second example is from the world of sustainability. Yes, you can see now. Okay. So in the sustainability world, EPRI has been working on what's called priority sustainability issues over the years. And in 3 iterations, we've gone out and at a sector level said, here are the identified priority sustainability issues. And that's important because that's kind of the starting place, or at the company level, sustainability issues are the starting place for identifying where you're going to sort of focus your attention on the issues that are most important for reporting and for tracking and keeping track of metrics and things like that. So the usual way of doing that is very manually intensive, and we heard about new AI-enabled services that were available from new companies that were springing up. We saw those in these 2 reports at the top. So after assessing and looking at what kind of services they provide, we saw that a company called Dataran was doing a service that's basically very similar to what we do manually. So we decided to kind of look at these processes simultaneously, track the labor hours and the costs of each of these approaches. And the results are again, freely available on the website that I showed before, and I'll pop again in the link. So the EPRI version, again, manually intensive, we're looking through 56 curated documents, and that really means reading through something, identifying a sustainability topic, and entering that into a spreadsheet. There's more that goes into it, but that's the basic idea. On the other hand, the AI-enabled is really tapping into big data and natural language processing and analysis. And so it's able to accommodate a huge amount of information, so 25 times the number of reports, and that doesn't even include, tweets and news articles and things like that. So that's one advantage there. Secondly, these are the results which are kind of nerdy in the sustainability world, but essentially what you're getting is a list of topics from our manual method and from the AI-enabled method about what are the top sustainability issues in the electric power sector. So what our findings were is that they were basically the same results. There's some differences, but mostly it was kind of what I would call phantom differences. So overall, the AI-enabled approach allowed a huge amount of data to be considered versus the manual approach. It saved a lot of labor. It saved 25 times the labor. And even when considering the cost of having a license to access that service, it was also much less costly. But you still need humans to understand what the results of that service is. And then if you're saving all that time, then the humans have the ability to do a rapid refresh of any new sustainability issues that may have come up, anything that's trending. And I would say that AI is only a black box if you don't open it and see what's inside and what it's based on and what its rules are. So that's kind of the overview that I had. I was going to stop here on this slide, and you can give me a time check and see if we have time to take questions and take a look at some of these other topics if you'd like.
Thank you. Yeah, we're actually doing great on time. We have maybe 8 more minutes. So I'll open it to the audience. Feel free to unmute yourself or just type in the chat.
And while we're waiting to see if we have any questions, I'm going to put in the 2 websites that I mentioned. The first, epri.com/env-data-sci, and the second was that story map about the deep learning for wetland identification.
So I think, Becca, you can pick the 3rd case study then.
Okay. Can I ask a question, Kari?
Oh, yes, please.
Certainly.
Yeah.
Sorry, yeah. Hi, Becca. Very interesting. I was just curious. I found it very fascinating when you were showing this difference between the data on the wetlands from the satellite and this other data. And it looked like there were like some kind of dots that were out there in a field or something nearby the transmission line. And I was just curious because I don't know much about wetlands. Is that really what a wetland looked like? That it's kind of dotted around like that? Or and so is that kind of an issue with the original data, or is it? I mean, like, where is the ground truth? Kind of. I was just curious about that.
Yeah. Yeah. So I think one thing that's interesting with that output is it was just basically it's either a wetland or it isn't. So, you know, there's a threshold there that we made the decision as to, you know, let's say this is a wetland. The next step that we're going to do is have more of a heat map to say, you know, this is a higher probability of being a wetland and this is a lower probability of being a wetland. But there can be some areas that may be inundated in some years and not inundated in other years. So that may be sort of a little bit of an anomaly. But if you want to be conservative, you would really want to know even the areas that had a chance of being a wetland or not. So, yeah, there will be little bits and pieces here and there.
Yeah, no, thank you. It's super interesting.
Thank you. Other questions?
Any other questions from the audience?
Well, I can mention just a couple others. Since you brought up earlier the vegetation growing into the transmission line rights of way and how, you know, that's an issue because they can fall into the lines and cause blackouts and cause wildfires. So there is a little bit of work that we're doing at EPRI to look at commercial satellite data that's of a very fine resolution. I believe it's 10 centimeters, I could be wrong. And to get some ground truth data about trees and understand, here's the ground truth of trees that we think are stressed or dead, and here is what the algorithm tells us is stressed or dead. And we think this could be helpful in the future because there are a lot of service providers that are, you know, saying we have this service to take a look at what's encroaching and what are stressed and dead trees. And so perhaps we can have this, you know, ground truth data to sort of do a bake-off of different services. That's something that we've been talking about a lot. And then I'll mention that we've also done some text mining work with Endangered Species Act documents to try to automate the identification of best practices for species. And it was very difficult to try to find someone or an organization that had both expertise in natural language processing along with Endangered Species Act. So there's, you know, I said to my colleagues, I think there's one person in the United States that has both of those kind of expertise, areas of expertise. But of course, you can try to get a generalist and a specialist together. So that's kind of an interesting challenge that we come across, and perhaps you have as well, in trying to marry the world of AI with the world of environmental issues.
Yeah, absolutely. I think that's true for any new emerging area. Is there's sometimes going to be nobody in the world that's an expert in that particular thing, which is exciting because it means we all get to learn something new and hopefully make an actual contribution that hasn't been made before. With the vegetation management, I think you could also use the tool you mentioned as sort of a screening tool. So what are potential areas that humans should go out and take a look at, rather than the way it's done right now, which from my understanding at the distribution level, it's a lot of manual. I have to call up Excel Energy and say, I think there's something touching my power line because it's sparking at night. They don't have full visibility into what's going on in the distribution network.
There you go.
All right. Any last words?
I would just say, you know, learn more. Go to our website, and we have all of our research from this initiative available, especially the literature review that's broken out into the different subject theme areas, I think can be useful for folks. And if you have a research idea or an idea for pilot testing with a utility, please let me know. My contact information is over there, and along with our broader ai.epri.com there. And if you do know electric power utilities who are interested, or if you're on the line and you're interested in pilot testing something, we would love to do that, especially if there's a way to kind of do the standard approach along with the AI-enabled approach. We think that's very helpful. So thank you so much. I really appreciate having the time to talk with you guys.
Great. Thank you, Becca. Our next speaker, let me get his slides loaded.
Dr. Baker, I'll just do a sound check. You give a thumbs up if you can hear me. Okay.
Yep,
Excellent.
I can hear you.
Thank you.
I moved.
I'll just.
Sorry, I have to go through Becca's slides too.
Myself while you're doing that. Hi, everyone. My name is Issa CA, and I work at SAS, and I help lead a lot of our Data for Good initiatives. And so I'm excited and honored to be just sharing with you guys a little bit about our Data for Good program and some of the environmental impact projects that we've done. But more importantly, I wanted to, I guess, ask an important question, and share with you, and this might be even more valuable to the crowd here, is just share with you a little bit about our process of how we contribute and got into, just the mode of trying as an organization to figure out how, yes, we are a commercial entity. Man, there's still, we're still a team of passionate people who care an awful lot about social issues and the big problems in the world and how we might be able to contribute to some of those solutions. So just next slide, please. So just real quick, for those who don't know SAS, we are a large privately held software company. We've been around 46 years, and we've, in our history, we've known for our software that does statistical analysis, right? We're the quantitative science tool makers, but for us, what we're really about, and this picture right here talks about the 17 goals of the United Nations, which is what we've wrapped our Data for Good program around. I've been at SAS 17 years. For 12 of those years, I managed our relationship with the United Nations and tried to bring our enabling technologies around analytics and data science to help the UN with so many of the important issues they're working on. And so it's not a surprise that we've wrapped all of our Data for Good projects and programs around the goals of the UN, of which environmental impacts, it's easy to argue, affect all of these goals, right? So next slide, please. But at the end of the day, we're an organization that tries to be all about curiosity, right? We promote curiosity. We try to make tools that help curious people find the answers to the things they're curious about. And we ourselves are curious about, okay, how can we take, the resources that we have and how far can we move that needle on social impact? And so the question I'll pose to the audience here, and the very first part of our journey was the question of, okay, how do we take what we do best in the world, right, and use it for social impact? At the end of the day, I tell a lot of our Data for Good partners, my technology is really just plumbing. It's useless without the thoughtful questions and the expertise that our Data for Good partners, who are on the front lines of so many of these important issues, bring to the table. The challenge for them, and I work with a lot of nonprofits who oftentimes are small but mighty entity, and most of them can't afford a full-time statistician, or even if they can afford some data scientists, there's always another facet of data science that may be complementary that they don't have access to, or even if they did, bandwidth is always an issue, right? Because in the whole analytics process, the moment you answer one question, it invites 5 other questions to pop up, and that's the innovation process as well. It's messy, it's and you sometimes feel like you can't ever get to all the questions, and so for us, we feel like we're some of the best. We have some of the best people and employees around data science and data and analytics. But how do we use that for social impact? And so our program, we on a pro bono basis, we will put together teams of analytic employee volunteers, right, who will take the skills that they do commercially, the skills that they offer, the things that they do commercially, and allow them to use some of those skills for these passion projects. So for example, predictive asset maintenance is something that we do for, for the railroads and for the Lockheed Martins of the world. But, the folks who are doing the predictive asset maintenance analysis have that exact same skill set that they can use to help an NGO in Africa figure out where to place the wells, right, in some of the poorest and arid countries in Africa. Because I'm told that, 20% of all the wells out there are going to fail at some point in the next, year or two. They just don't know which wells. So, but more pertinent to today's conversation, I want to share with you 3 or 4 case studies of our Data for Good projects that involve AI. This was one of our first ones that we did about 3 or 4 years ago to help track endangered species, right, with AI. So, what we see here are the cheetahs. Very, very few people can I guess afford to take a team of experts out into the bush, right, and tranquilize a cheetah so that they can track its well-being and so forth, right? And that process is not only expensive but also pretty traumatic for the animal. And what we ended up doing was we got our AI experts together with the scientists and biologists in the field, and they had this idea of saying, man, we may not all be able to track a cheetah, but how many footprints does a cheetah leave every day, right? And can we take a picture of that footprint? And it turns out that the paw print, and it turns out that the paw print of the cheetah is good enough to be a unique identifier of that particular animal. And so, yeah, when you think about how many footprints a cheetah leaves everywhere, and then when you incorporate the idea of, in that project, like citizen data science, where everybody's got a phone now, everybody who's out on safari, and as they come across tracks, they can just, take a picture of one and submit it. And so, so it was a pretty neat project for us to be able to help these scientists figure out how to track these cheetahs on the land without having to tranquilize them. And and what's interesting is, and again, in the spirit of curiosity, when we share these stories with our customers who would come visit, we had some law enforcement customers who said, "Hey, you know what? That's fascinating." And this was about 5 years ago that we did this project. That's really fascinating. Can we consider looking at like human footprints, maybe, at crime scenes? Or, we had manufacturing customers who came and said, "Hey, this is wonderful technology that I think would be really applicable on our manufacturing lines," right? And so that was an example of where our curiosity in terms of just addressing a social issue led to best practices that helped in other everyday scenarios. Next slide, please. Becca, I'm so glad that you mentioned that last example about natural language processing and biodiversity, because that, NatureServe is an organization we worked with about 2 years ago. If you guys ever wonder who it is in the world that decides whether a species is endangered or critically endangered and where they fall in that spectrum, it's our friends at NatureServe. And for them, they take some of the best scientists in the world on a particular species, and it requires a manual process of looking through academic journals that can take up to 100 hours, right? And so we brought our experts in natural language processing alongside these experts, looked at their manual process, and we were able to get and create a working prototype for them to get that 100-hour process down to minutes. And so we are currently in the process of helping them figure out, okay, how do we find more data to be able to run through this thing and to help with all the species that are on the IUCN Red List and so forth of endangered animals and species. So what was also really interesting about that project was, and this is something that not many people think about, even at SAS, and we live and breathe data and analytics all day long. Most people think that you need to get your data ready and do a lot of processing, what we call data management, right? Before, to prepare the data for analytics. We actually, in this case with NatureServe, flipped it around and said, hey, let's use analytics to help prepare your data for analytics, to enrich that data. And when you're working with rare species, they we actually, our natural language processing tools and our analytics enriched the species on rare data that they had going back 100 years and allowed them to use an extra 50,000 rows of data that their normal data processes would have thrown out, right? And so again, when you're working with rare species data, there's not much of that stuff to go around. So that was a huge win, and a wonderful best practice that came out of that project. Next slide, please. And the most recent project that I thought would be appropriate to share with you guys is how we, in the last year or two, year and a half, worked with a research institute to combine AI and computer vision and the needs of the Amazon rainforest, as well as crowdsourcing, and mash that all together to figure out, okay, how can we just do something that hasn't been done before? There are a lot of really smart people working on AI. And so this was kind of our slice and our take on something that might be new and helpful. So if you go to sas.com/rainforest, you can interact with this environment yourself. But what we did, next slide, please, was we just asked people to come and look at satellite imagery, right, of the rainforest, of the Amazon rainforest, and just simply click on an image where they feel like they see human impact, right? And if they needed examples, that we had a little tutorial that was created with these experts, and so that simple act of clicking on an image where you feel like you see human impact or not was actually going to train. That action was training an AI model that, as we've already heard, right, can AI model doesn't get tired. It just needs to be, you have to train it to get it accurate enough, and then there's no bias. It doesn't get tired. It can go through hundreds of thousands and millions of images, pretty reliably. But the downside is, and to Becca's point about how you still need humans, that top left square, to the human eye, it's pretty obvious that's probably a river, because of how squiggly it is, not a road. But a computer model doesn't know the difference between a river and a road until you tell it a few hundred times that, hey, no, this is a river, no, this is a road, right? And so again, that simple act of clicking on, where you see human impact or not, went to train an AI model. And just our asking that question about, okay, how do we mash together citizen science, citizen data science with, the experts and AI, and the needs of the Amazon rainforest, has sparked an awful lot of additional questions that have come from that project, right? Because, for example, the satellites that take these pictures fly overhead every 3 to 5 days, right? So once we start collecting historical data, we can start looking at, okay, there's previously no human impact here, and now we're starting to see some human impact here. And as we get that historical data, we can now do some more advanced things like predicting how quickly human impact is going to spread, where is it spreading to and coming from, and so forth. So that was a year and a half ago. And next slide, please. Oh, and by the way, people, you can go in and look at the areas that have been classified. I even got feedback from some people saying that, for that person in your life whom you don't know what to buy them for their birthday because they have everything, like they've gone in and they've said, hey, I profiled for your birthday, 1,000 square kilometers of Amazon rainforest, right, in your name. So I thought that was, people are creative, right? But we just needed a way to harness the creativity and the energy and of the masses with something useful in this case. Next slide, please. But the ideas that have come out of this from that initial question now, and these are just phases and questions that we're actively working on but haven't delivered on yet. But number one is, okay, we looked at human impact versus no human impact. Now, the corpus of the data that is human impact, can you tell me what kind of human impact that is? Is it a gold mine, which is what you see on the left image there? Is it like selective illegal logging, right? Which, I mean, to find one brown speck in a sea of green, right? And to come back 3 or 5 days later and find 1.5 brown specks in a sea of green, right? That's something that the computer is uniquely capable and trained to do if we train it right, much better than my eye can. And then, ore is another driver, deforestation, and this seems to be the ground zero of all the scientists that we work with in the Amazon, because as they look at carbon, as they look at biodiversity, they really need to understand, well, what's happening to the land, right? And what are the predictors? For example, the Amazon Conservation Association says that really high percentage, like 95% of the forest fires, you know, come off of roads. It's a lot cheaper to burn forests down than to bring in all that equipment and to cut it all down, right? So it's stuff like that where once you understand it and you can model it, then we can help them be more reactive and proactive. Next slide, please. Another whole family of questions that came out of this was around wildfires, right? We're getting into fire season. A couple of years ago, the world just, all we could do is sit around and watch while the Amazon was on fire. And it's not just the Amazon, like Dr. Baker said, it's in Colorado, it's in Greece, it's in California. And so this is an issue, a global issue. And so, some of the questions that have come into us to say, okay, but in the Amazon, and this can be used elsewhere, how do we detect, can you automate the ability to detect, whether it's an actual fire, or, and when there is a fire, like we need to know sooner, so that we can notify, right, the right organizations and authorities. Or can we calculate and predict where the most fire-prone areas or how quickly the fire will spread? And then all these topics are interrelated, right? In terms of carbon footprint, can we quantify the carbon footprint of each fire and use that model in calculations as we start looking at the next slide, please. Some bigger questions around, okay, this is what my friends at Amazon Conservation Association call carbon flux. Right? The Amazon has been a carbon sink for the world since forever, but there's certain portions of it that are no longer carbon sinks, no longer absorbing carbon, but they're starting to become sources. They're putting out more carbon than they're bringing in. Some scientists are even arguing that, hey, we've already crossed that line where collectively the Amazon is no longer a carbon sink, but is starting to become a carbon source. Right? So how do we quantify that? How do we automate the detection of that? And so that the right conversations with the right data and metrics can go to fuel some better conversations with policymakers, because the Amazon is spread out amongst, I think, 8 or 9 different countries, right? And then just the predicting in terms of, predicting, okay, these areas that are red, how quickly are they popping up? Where are they most likely to pop up next? And for example, if one of those red dots, which symbolizes carbon source, if it happens along that line of red dots, that's concerning, but maybe a little less concerning is something that happens on the far left side where you still have, that really precious area of pristine Amazon forest left, right? So, and then next slide, please. So anyway, I share all of these case studies, certainly not to talk about how great SAS is, but just as an example of how, we just asked one question and look at all these other questions that came out of that, right? But it all started with us as an organization asking ourselves, how do we take what we do best and use that for social impact? And I guess that is my encouragement to everybody here as an individual, as an organization. If you're an accountant, perhaps what can you do to contribute? It'd be easy to just pick up the phone and call any of these nonprofit organizations, right? That could use somebody with skills like that. I mean, all of us have something that we can contribute to the fight, and it's just a matter of figuring out. And most of us, I would dare say, can't take a lot of time off to go live in the Amazon for a spell and be boots on the ground. So but I would dare say that all of us have access to resources and skills, right, that maybe have never been put together before, but when you do, all of a sudden that's the innovation process. So anyway, I will pause there for questions, but thank you again for your time.
Super interesting, thank you. I'll open it up to questions from the audience first, either through the chat or if you just want to unmute yourself.
I went ahead and sent out our Data for Good website where you can get some more details on some of these stories and others.
I really like what you ended with we each have our own skill set and we should not assume that, we can all do exactly the same thing, but that's the beauty of what helps us address these large scale problems.
Well, and Can I just share real quick a story that I didn't talk about? Back in 2015 with the Nepal earthquake, getting some goosebumps just thinking about it. So I picked up the phone when the Nepal earthquake happened, and I called my friend at the UN who was responsible, 50,000 families, right, who were out of a home, and they were sleeping in tents out in the open fields, and he was managing those camps. And I said, hey, how can I help you? In the past, we had analyzed data for them and helped them make better decisions on how to handle the displaced people. And he's like, I don't think you can help me this time, Issa, because my most pressing question right now, the thing that's occupying all my bandwidth, I don't have data for. It's how do I get, how do I protect the people, the 50,000 families sleeping in open fields, right, from monsoon season that's coming in 4 weeks, right? Where hard driving rains, and the only thing worse than that are the snows that come on these people after monsoon season, because they're right there at the base of Mount Everest. And in that moment, I said, hold on a second, Brian, and I had access. I just turned my chair around on my desk, and I had access to 300 million rows of data of everything ever bought and sold in the world, of the UN trade database, UN Comtrade, and I said, India, right next door, #1 exporter of that sheet metal roofing that you just told me you needed. I was like, oh, but wait, don't buy from India, because Nepal, and I didn't know this, he didn't know this either, Nepal ranked 7th. So do not flood the market with, foreign sheet metal, because you've got a lot of capacity in country, and you might create a second disaster if you do. So, and I just happen to be the guy in that seat who could click the mouse 3 times, right? So all of us have access and a unique perspective on the problems, and a unique solution that we can offer.
Yeah, and Isa, you and Becca both brought up the sort of hybrid model where human interaction closes the loop between the AI algorithm and the actual impact on the environment. But I'm just curious, have either of you received any pushback from people thinking, oh, AI is not going to be a tool that helps me. AI is eventually going to threaten my job or do something that's negatively impacting my community?
I think sometimes when I'm presenting to a general audience, I'll get the weirdest questions at the very end. They'll be like, but what about this horrible example of AI? So for a general audience, I've started putting in this, like just an icebreaker question, like what's a good example of AI and what's a bad example of AI, just to kind of get it out in the open, talk about the Terminator. But I think it's helpful to then point out some examples of AI for good, and how it can really be brought to bear to make the world better. And then we get on the same page. But yeah, I've gotten some hesitation, some really strange off-the-wall questions at the end of a talk.
Yeah, I don't have any nearly as exciting stories as Becca has there. I think by the time people get to me, they understand that, hey, we play in that AI space. And so, but for us, we have a responsibility, right, to do it ethically, and to try to democratize the idea of like, hey, here's where AI has been really helpful, but here's exactly where we needed people. And we're very sensitive to that in our storytelling. Yeah, because AI itself isn't going to solve the world, but man, there's situations where it's incredibly, incredibly helpful.
Yeah, I get a lot of pushback just from utility industries because, as mentioned earlier, the power grid is one of the most complex systems to operate. So changing the way it's been operating for decades is scary, and it could result in something bad. But at the same time, humans also make mistakes. So combining those two might actually end up with a safer solution than just one or the other. Any last questions for our speakers? Okay, thank you two so much. Feel free to stick around for the panel if you'd like to continue answering questions. We'd be happy to have you. But otherwise, I really appreciate your time.
Thank you.
Thanks, everyone.
Thank you. All right, so we're moving on to our panel of speakers. If you all want to, I think if you just turn on your cameras and unmute, I can introduce you. Here we go. So we have 4 speakers with us today. We're going to go around and they're going to introduce themselves. And I want to make this really an interactive session because how often do you get a bunch of energy and AI experts in one place at one time? So please feel free to participate, answer questions, share anecdotes with our panel. Why don't we start with Marcus? Why don't you introduce yourself to the audience?
Hi, I'm Marcus. I'm from Berlin, Germany, actually, so it's quite late here. So I hope
Thank you.
I'm still in a good mood. No, I have been working as a PhD student at TU Berlin for the past 7 years in a very applied computer science chair, where we worked on applying machine learning in my team to the energy sector. So that's why I guess I fit here quite well. And we've worked with our local DSOs and TSOs and looked where we can help and support them with AI and machine learning, because I don't know how it is in the US, but here it's very in the beginning for at least the DSOs. I think the TSOs, since they're a bit bigger, they have some more resources to be a bit more ahead. So that was quite enjoyable. And then I noticed now that I feel what I've been doing there, I can now do more effectively right in industry. So that's what I have been doing now. I transitioned into industry now. So I'm working as a consultant now since beginning of September in a small consultancy, not just focused on energy sector. So right now I'm working in the transport sector, but yeah, also very interesting and also very relevant to help out there to enable people to apply AI also in those fields. And yeah, and here I'm today in my role from Climate Change AI, some organization that probably some of you know, where many researchers and industry people come together to basically provide resources and bring together people that are working on the field of climate change and AI. And there I'm working in a content team where I work on providing resources to people and yeah, to also enable them. Yeah.
Well, welcome, and I appreciate you sharing your time with us on such a late schedule. Arun, do you want to introduce yourself next?
Hi everyone. My name is Arun Vishwanath. I'm on the other end of this world in Melbourne, in Australia. So it's about 6:30 in the morning. So very good morning to everybody on the call. I work out of the IBM Center for Applied Research in Melbourne, Australia, and I've been with IBM for about 7.5 years now. Largely, my work is centered around energy management in the areas of smart buildings, data centers, and also in the application of renewable energy for kind of matching demand in some of these locations. So that's largely where I come from. And of course, being in industry, one of the things that we are particularly interested in is taking some of these research ideas into the field, into the real world, to try to validate and kind of learn from adoption in the industry or deployment in the industry, and how some of these ideas can be fed back into research to kind of enhance and refine some of the models that we had built earlier. So kind of closing the loop from an industry / academia research perspective. So that's where I fit in, hopefully, in this panel as well.
Yeah, great. Thank you. Also, thank you for joining at an early hour. I didn't think that originally, but we do have people from all over.
Yeah.
Lena, do you want to go next?
Sure, happy to. Yeah, so hi, my name is Lena Roald. I'm an assistant professor at the University of Wisconsin-Madison. So I did my PhD work in Europe and at ETH in Zurich. And so I've been kind of going through, the start of my career was focused on research, kind of in integration of renewable energy into the power system. And then more recently, I work in the field of electric power systems specifically, and I've been focusing on the integration of renewable energy into the system. And then more recently, we've kind of taken a focus more towards climate change adaptation and understanding the impacts. I mean, for example, of the forest fires that Kyrie mentioned earlier. how these kind of threats interact with the grid and the operation of the grid. And so a lot of the work I do is related to optimization of electric grids. And that then involves a lot of data, both as an input to optimization problems, but also sometimes, I mean, more recently, I guess, there's been an increasing focus on trying to help also understand how machine learning methods can help solve those problems. So yeah, that's sort of the span of the research that we are doing.
Thank you, and thanks for joining us. And then Xin, do you want to introduce yourself?
My name is Xin Jing. I'm with the National Renewable Energy Lab, or NREL. So I'm a senior researcher in the Building Technology and Science Center. I'm also leading the sensor control portfolio for the buildings program at NREL. So my research mainly focuses on building grid integration, machine learning and AI applications in buildings, trying to make buildings more efficient and more resilient and more interactive with the grid systems. I've been with NREL for 7 years, and really my honor to be here, be part of this panel.
Thank you, Xin. So thanks everybody for coming. I'm going to kick us off with a question before we open it up to the audience. And it's a bit of a challenging question, but what do you, in your mind, maybe data availability, maybe pushback, maybe risk assessment, do you think is the biggest roadblock to implementing AI technologies in the energy sector right now? I'll give you a second to think about that. And then whoever wants to go first, please feel free. And it doesn't have to be the biggest, but maybe one of the challenges you've noticed in your own work that prevents a lot of these technologies from being easily deployable.
I'll kick it off if you, okay. Yeah, I certainly think, at least again, putting an industry hat, that availability of data, using it widely, or even using it for practical applications, right, can be a bit stifling, because it's all, you have a single client who can share the data, but it is just for a specific agreement for a project that somebody would like to do, but then everything else is off limits, right? So some of the examples that we have seen is, in the case of a certain building, maybe it's only for a small group of researchers within IBM who can work on that project to kind of gain some insights and move the efficiency of the buildings forward. But it kind of ends there, right? The data is often not very publicly available, and perhaps even the solution that we end up building therefore becomes very, very specific to that one application. So it's almost you build one solution for one building and then another solution for another building, but you don't really see the universal application of that solution across different types of buildings and use cases. So I think, from my point of view, a personal experience, this has been one of the bigger challenges that I have faced in my prior work. And building general purpose models to be able to replicate it elsewhere has often been a challenge from my side.
I can go next. So I fully agree with around observation, and scalability is indeed one of the big issue in the building space. So nowadays, most buildings are still using schedule-based rule-based control, and people start working on model predictive control, trying to make building more intelligent. But there's a big scalability issue, like the model you created for one building doesn't work for another building. So that's why we are start looking to other methods like reinforcement learning and the transfer learning. Like if we can train a building controller on one building or one type of building, then we can directly transfer the controller to similar buildings or building of the same portfolio with little calibration time. So that's the one direction we're working on. And another big gap I have been seeing is the privacy concern. So as most of you know, AI and machine learning technology require data. So due to privacy concern, like when you want to obtain more data from an end user, they may have some concerns, like will my information be shared with third party without my knowledge, or what happens if there's a data breach? So many AI algorithms can only use the data that's publicly available, but if they can obtain some additional information from the end user, or input from the end user that can greatly improve the accuracy of the AI technology. So that's something I have been seeing with my own experience. And one more thing I want to mention is another gap is the equitable access to the AI technology. So when we deploy AI technology in the real world, it's most likely the affluent neighborhood or affluent user have access to the technology. But for low-income community, they may not have the equal access to the technology. So when we keep working on this area, I think we have to keep that in mind. Like, how can we make sure this AI technology we're creating can also be can also benefit people of different income level, people live in different areas. So I think that's a big question we have to keep in mind when we research and working on deployment.
Yeah, maybe I could also react to that a little bit. So first, I was also just thinking about this. I mean, what we're mentioning here, I think a very good point about the data being proprietary and not available and things like that. I also just the data curation can be really hard. Like, even if there is data and even if you have access to all of it, like just having good quality data and curating it in a way that allows you to do all of this, I don't know. I mean, hopefully, maybe that is a place where there's also being progress made. But yeah, I mean, having access to the data in a kind of streamlined way is oftentimes a challenge. And then I think of it as an educator, right? That we need to educate students, and that we need to educate more people in becoming fluent in using this kind of methods, so that it can become more accessible, that there's a larger people who have a fluency and kind of know both how to use and develop tools and use them, but also that they are able to kind of actually critically assess the outputs of these type of models that are being used, right? And that comes back to some of the things that you mentioned, Jin. And you know, essentially, if we are going to use sort of this type of methods for decision making, it is important to be really clear that we are making decisions. And so, kind of coming from this sort of background of optimization, we have an objective function. There's something you are trying to achieve. And although sometimes that is very explicit, as in the terms of optimization, you have kind of a goal that you're trying to advance. But I think thinking properly through what is that goal and how is that goal, I mean, how do we choose that objective function or kind of what we are, I mean, that isn't, it's a choice. So you can, I mean, in some of the work that we do, you know, for example, if you look at power restoration, you can see that the way you deal with the input data, you know, how you account for availability of renewable energy, for example, at people. If you have a grid that has experienced a major outage and you have to prioritize repair of certain parts of the network, how you take data about which people actually have access to energy through distributed generation, be that a solar panel or a diesel generator, if you have knowledge of that data, you can use it for something. But also how you choose to use it actually impacts quite a bit who is getting access to electricity first. And so, you know, there are choices to be made. And I think that is something that the technology is not neutral, and we should be aware of that.
Right. One good example was this.
Oh.
Go ahead, Marcus.
Go ahead if you want to add to that.
Okay, just one quick thought. When the February Texas blackouts happened, there were a lot of people complaining that, you know, if you take a look at the downtown where more affluent people live, the lights were still on. And then you take a picture of, or you look at the satellite imagery of lower income areas, and those are the ones that got the power cuts. So it's not just about, you know, equitable access. It's also what Lena mentioned about making sure that the algorithms are restoring or providing operational equity as well. Marcus, go ahead.
I mean, I just wanted to say, I mean, data is definitely also one of the big challenges, of course, always. I mean, as a researcher, it's hard to get the real life data, and you always just work on, I don't know, I've worked a lot on the Irish data set to my forecasting work, which is, of course, a very hard bias. But what I wanted to connect to the point that Lena made regarding education. So I think she mentioned students. So I also see this as a very big, hurdle, a big hindrance, because it's such interdisciplinary nature using AI in any field that's related to power systems or climate change or whatever, because it's always interdisciplinary, and to do some impactful work, you need a big understanding of the actual domain and the AI world. So I've been to power system conferences where I've seen people report their errors on the training set, and because they don't know how to apply the methods really well. And then on the other side, machine learning experts, they've in the power system, I mean, there's such a huge body of literature on forecasting and NILM, non-intrusive load monitoring, to an extent where you say, okay, I mean, non-intrusive load monitoring, I would say, is not such a big issue, but since there have been these data sets, that's where many machine learning researchers worked on. So having this connection by people that understand both worlds, can speak to both of the people and connect these people, is very important. And I mean, this is definitely education necessary in the universities or whatever, but this will, of course, also just trickle down into the industry in the next 5 years or whatever. So if we want to do something now, then of course also some sort of education needs to be done in the industry itself. So just today I've spent a day with educating managers at a company, basically about just giving some, like a 2-day course on artificial intelligence and machine learning, just giving them the basic vocabulary, giving them some ideas of machine learning. And I think this is also very impactful, because I mean, we did like some exercises where they could break down some ideas they had, where they just had a vague idea that maybe machine learning could help them, and that using a canvas or something and just break down the problem. And it was so useful because you could see that they didn't understand anything at the beginning of the course about that, and then at the end of the course they could break down their own ideas into something that could eventually be actually implemented or so. So that was quite interesting to see. So it's not just the education in universities, but also in industry, I would say.
Yeah, absolutely. Especially as we move towards electrification. I've heard secondhand, I'm trying to get a heat pump installed in my house to replace the gas furnace. And the number of HVAC installers who know how to install a heat pump, it's still a relatively small number in certain cities. So it's, how can we use tools to help assist electrification, expedite this process, and decarbonize faster through the use of AI and education? Another thing that, just speaking of students, it seems like an increasing number of them want to do something in the climate change space. Almost every week I get a student asking me what they can do to help climate change. And it's sometimes, yeah, it's really, it's both inspiring and worrisome, because you can tell they're also very anxious about climate change, as probably we all are. But some of them tell me, oh, but it seems like, these AI algorithms are increasing carbon emissions because they take so much electricity to train. And so I wanted to ask maybe Arun about this, since he works on data centers. Where's there's an obvious trade-off between using increased computing power to lower emissions, but also using increased computing power that in turn increases emissions from that computing power. So what are you seeing in this industry that sort of addresses the increase in computing power needs?
A good question, Kyrie. So one of the things we are trying to do, essentially to tackle these kinds of problems, is trying to understand what is the carbon intensity of the electricity grid powering up these data centers, right? So as we all know, the composition of the energy generation on the grid can vary over time. And obviously you can see periods where because of renewable energy generation being high on the grid, your carbon intensity is quite low, can become low, and kind of vice versa, right? So in Australia, I think luckily, I think as many of you may know, this huge influx of solar in the grid at certain times, and therefore, and of course, in around the world is something that we are constantly monitoring. So one way to overcome this issue of AI consuming a lot of carbon specifically would be to do two things. One is predict how the evolution of carbon intensity is going to evolve at multiple time scales, and then kind of dynamically dispatch these workloads, namely one of them examples could be training of these AI jobs to the data centers in both space and time, so you can exploit the fact that the carbon intensity is getting low at different points in time, right? So typically, some of these AI jobs, training jobs, are batch jobs. Essentially, they're not very real-time and centric. So you can afford to train the jobs when the carbon intensity of the grid is the lowest. So that way, you kind of minimize the carbon footprint incurred to train these AI jobs and AI models. And in terms of the energy, well, you're using renewable energy as to the extent that you possibly can. So I think that from a win-win perspective, you can keep the carbon low and maximize the use of the renewable energy, right? So that's one aspect of how we intend to bring this idea into the field. And secondly, of course, is to use better and more efficient machines. So IBM does come out, and latest there was a new power power processor that we released that has significantly better carbon footprint compared to several other technologies, right? So I think this combination of the state-of-the-art hardware combined with state-of-the-art algorithms that track and forecast electricity on the grid and move your workloads, I think would be one of the solutions in trying to reduce the impact of these AI training jobs in carbon. That's what we are pursuing from our side.
Yeah, I think a similar trade-off exists in buildings because we are moving towards electrification, which means, changing our cars from gas vehicles to electric vehicles, changing our furnaces or ovens. But there's also a trade-off because not everywhere in the country at every time is there the cleanest electricity. So I think Shin has worked on something in that space with making sure that buildings, as they decarbonize, continue to stay clean.
Yeah, so that's right. So we're working on one project right now. So looking to how we can operate building, reduce the operational carbon emission from buildings. So it's more like exploratory research. So as people discussed in the previous sessions, like the carbon intensity on the grid is time varying. So if we can take a look at the somehow get a signal or prediction of the carbon emission in the grid, and if we can shift the building loads to a low carbon time period, then it can effectively help us to reduce operational carbon emission in buildings. So this can be done by load shifting, like if you can schedule your cooling load or heating load when the carbon intensity is lower on the grid, then you can cool down space, pre-cooled space or preheated space. So it can reduce the energy consumption when the electricity on the grid is still there compared to the current time. And also we can store those energy using electrochemical battery or thermal storage and use it later. So that can also effectively reduce the carbon emission from buildings.
Nice. Yeah. So I don't know. Yeah. Oh.
Yeah. So and we also found when we design this kind of control strategy, we have to be careful because you may end up using more energy or causing more higher utility bill for the building owners. So so not making the building responsive to carbon is good, but even better if we can look into multiple objectives when designing the building control technology. So like MPC or other kind of technology may be a good fit here.
It is super fascinating to hear you talk about this. I mean, we also, I mean, we've had an NSF project for a while. I'm working with a collaborator at the University of Chicago, Andrew Sheehan, who has a long track record in working towards zero carbon cloud computing. So that's, I mean, his really work. And, very interested kind of in this idea of, how can you use excess renewable energy that is currently being curtailed to power computing. It's coming at it from the grid perspective. Yes, I mean, I completely agree that it's not only, there's data centers, which are huge loads. And it's very interesting because data centers have this unique capacity to not only shift load in time, but also in space, right? But then of course, any other load in the grid as the buildings and so on also have this opportunity. So we're currently working towards also understanding better, how do different metrics for shifting load actually impact the carbon emissions. And it's been very interesting to see that in terms of demand response, I mean, I think many people have this implicit understanding that if you follow a price signal, then you are kind of helping the grid. And by helping the grid, you should integrate more cheaper energy, which hopefully should be renewable energy. And I think this is something that, at least in the field of power system, I feel like I have often encountered this idea that providing flexibility to the electricity market kind of comes akin to helping integrating renewable energy. But that's not true, right? Because the ISO, who would be, if you bid into the electricity market directly, you are working with an entity who's trying to minimize cost of electricity. Whereas if your objective is to actually try and minimize carbon, then some of the stuff that we've been looking at, which looks at carbon emissions at the more granular level, so at the nodal level in a grid, that shows that if you take it into your own hands and shift your load to the location where you have the lowest carbon emissions, you can actually achieve more than you can by providing your flexibility to the market. And that has been, I found very, very interesting. But the problem is that this granular level data is not being published by the ISOs. And so that is, I mean, one of the things that I'm very excited about, trying to leverage AI in order to try and provide better information in order to actually make some of this data hopefully available and widely available so that it can be used for a number of different applications. So yeah, also something we're actively working on. So interesting to hear that there are multiple people here who are also looking into that.
That kind of goes back to something Marcus said about how the data that's available drives what type of work people do, which is kind of an unfortunate situation because there might be a really big impactful change we could make. But it's just, oh yeah, we just have NILM data or we have price data, so we're going to focus on minimizing cost. I'm not sure the solution to that, other than to maybe convince different stakeholders that, you know, giving that data up is ultimately beneficial for them.
I am wondering if, you know, if you come up with a prediction, then hopefully maybe people will be encouraged to think that if there is value in data, that it might be something that is either from a regulatory perspective or from a business perspective. I mean, that there is interest in actually making this kind of data then available. Don't know, yeah.
And I think the whole data availability point also connects to the initial question now about the carbon emissions of AI in general, because this is also something I found in a research project I've been involved in my last month at the Institute, where we kind of looked into this and started a literature review into that a little bit and had some workshops on that, because there's not enough data to really say if AI models have a big carbon footprint or not, because I mean, there's those very big models like GPT-3 and there's some estimations of that, but then it's not totally clear if those really matter. I mean, of course, training those ones, it's a lot of CO2, but then, I mean, they're now partly trained for, let's say, research purposes. So you then can not really compare to how will it be applied later, because I mean, then you have to make a full life cycle assessment, because generally you will not train GPT again, GPT-3 at least, because it's now trained and you can use it as a pre-trained model in a way or via some API. And then you save a lot of computational power because you don't have to train smaller models downstream, basically. So this is now, I think there was the paper on foundational models that has been recently launched in Stanford, I think, where they discussed the sort of change in how those models are used. So you're not training it yourself anymore. And so you're just using it and for inference, which is a lot cheaper than training it. So I don't know, it's a very complicated question. And those sort of life cycle assessments and how it will be used in industry at some point is really hard to answer, because nobody can really say how often do you train what size of model and how often do you do inference. It's very application specific. Yeah, it's really so yeah, there's also a lot of data missing, I think.
Yeah, I've thought about that too, the life cycle emissions, because if you think about what Becca and Esau were talking about earlier with, you know, the AI can actually replace a bunch of repetitive, you know, human tasks, or somebody that's having to run a simulation a bunch of times. It might be more energy intensive up front when you're training the model, but ultimately it's going to cut down on a lot of the repetitive computations that somebody might be doing because it's a more efficient use of time and resources.
So what you also have to factor in, I think, in the real applications is also where does the data come from? So if, let's say you have a use case where you actually have to, let's say in the building sector, you have to put a lot of IoT sensors everywhere just to collect a lot of data, just to do your AI use case, you should possibly factor all this energy consumption of collecting the data, moving the data, maybe even the embodied CO2 emissions of all the sensors and so on in for that specific application, and then weigh it off with the savings that you might have. But then we've seen some remote sensing applications today in some of the talks where I mean, those satellite data is collected anyhow, it's laying on some servers. So if you do some machine learning and then get some value from remote sensing applications, you don't really have to factor in those emissions from the collecting the satellite data, because I mean, this is very general purpose and can serve a lot of purposes for your specific application, and because you didn't collect it for that purpose, I guess, and you just use that and you don't have to factor in. So it's very interesting, a very interesting research field, and I think nobody can give a real good answer yet on how bad it really is. Like even within climate change AI, there's some interesting discussions, because there's people coming from the climate science where they have these huge climate models, and they kind of look at us now discussing the carbon footprints of our models, and then they look at their models. Oh, ours are also pretty big. Why is nobody talking about this right now? So yeah.
Yes, I think that is also the problem of we're in our own little worlds and not really thinking outside of how what we're doing is impacting others. Like with energy efficient buildings, in some cases, energy efficient buildings, like Shin was saying, might end up consuming more electricity if they're smart and they're doing things like pre-cooling or preheating to minimize cost. We're not looking at the embodied carbon for the materials that went into constructing energy efficient buildings, which is also often more carbon intensive than some cheaper materials. I only have my panelists for 15 more minutes, so I will stop blabbing for a second and ask if the audience has any questions in this space they want to pose to the panelists. If there's no questions, I have quite a bit more. So
we have a hand, I think.
Hand up. I'm
Oh.
This panel. I'm seeing you.
Panos, please.
Hey everyone, nice discussions, nice material. I'm very excited with what I hear from you all, and it offers nice perspectives on many of the matters that I've been also working on and I've been seeing from colleagues in the industry. I've heard quite a bit about challenges and obstacles revolving around data access, data privacy, understanding, angling all this from our, let's say, a little bit more specialized view. How do we feel about industry adoption? I've heard about this a lot. Recently, there has been like full-blown projects, like 3-year-long projects, just about convincing a single operator or a single utility of how to learn of new artificial intelligence or machine learning tools, incorporate them and integrate them in their day-to-day and more critical activities compared to the more mundane activities. In between the sessions, we saw multiple videos of drones scanning transmission towers, tending to maintenance, but the more critical actions in the day-to-day are still far from adapting or even considering the potential of using artificial intelligence and machine learning. So what do you believe is the main roadblock, the main concern of, let's say, the utilities or the operators or the regulators to pave a path towards wider adoption of artificial intelligence and machine learning within the power system operation. And this, of course, Kyrie, we have talked about this a lot, the two of us, and we have came to multiple impasses. But yeah, if you want to mention any of the impasses that we have reached when we had our talks, please chip in your thoughts on this question as well.
I'll open it up to the panelists.
I could say something to that, maybe. I mean, I don't know. I think it's okay, so this is also just based on an impression I have, and that is that when it comes to certain applications, there are, for example, like forecasting, or, as you're saying, with drones and LiDAR and using that, when there are companies out there who are able to integrate this into their products, I mean, it seems to be adopting, right? I mean, I talked to a utility here in Madison, and they say, oh yeah, they use natural language processing in order to understand the outage reports and sort through them and kind of, manage that data. And the way I understand it is that these are well-packaged solutions that are then being adopted, and it saves, I mean, as Becca was saying, can probably save like 25 times the work, right? Similar also with LiDAR and power lines. I mean, there is software that takes LiDAR images and then build power line models for companies, right? And it's kind of fantastic that it's possible. And I think I get very optimistic because there is access to this data. I feel like I've spent a lot of time thinking about like, what are the limitations in terms of data that we have in order to do decision-making in particular, right? And so it's kind of exciting that some of that is maybe happening. But then much of this is in the longer term. When it comes down to operations, when decisions have to be made in a very short time frame, there's maybe a bit more skepticism. I mean, I don't know. This is just an impression that I have. That sort of planning is easier than operations.
Yeah, I don't work in the utility operation world, but I also get the impression that nowadays many of the AI or machine learning algorithm is still not explainable. So if you attend this morning session, there's a good discussion on explainable AI. So I think for those mission critical or operational systems, if the AI algorithm cannot be explained for its recommendation, then the system administrator or operator will have doubt when it's making a decision which they may not have seen before. So I think that may be part of the reason. But be happy to hear if anyone else have different opinion or other input on this.
I mean, I can also just confirm it's very similar, and my impression also from talking to a TSO here, and we've been kind of also talking about use cases. And yeah, I think the operators are very hard to convince. So I think there needs to be a sort of roadmap where it's, I mean, there's of course some research problems that still have to be solved regarding like making models robust, making them explainable. But then at some point, it's also more like a sort of how to convince the humans, user interaction sort of problems, because it's more about, at the beginning, it will probably be this like the operator still does the decision, and then the system gives them some sort of, hey, usually you would have acted in this way. Why do you act this way this time? And then get kind of doing this. And then at some point, maybe the system is providing some, hey, you could do this. And then at some point it will be the system does it and explains why it's doing it. And the operator still has the chance to interfere. And then at some point, maybe we have a fully automated system in whatever, 20 years or so. So, I mean, we come from a time where, like, at least in Germany, they've done a lot of like just via telephone up until very recently. So yeah, so I think this is kind of how it has to be done. Like, I mean, there are some research challenges, and once they are solved, it's more convincing the human is the challenge.
I think what Lena was
Just
mentioning
one
about
maybe.
if it's a fully packaged solution, it's a lot easier to adopt because then it has pretty understandable inputs and outputs, and you can use it for modular parts of the system. But when it's something like changing the operation of the grid or changing the way that things have been done large scale for decades, it puts doubt into our minds.
I mean, yeah, and then also the data which we talked about curation, right? I mean, I just followed in my home country in Norway, the system operator, the transmission system operator, Statnett, they recently appointed a chief data officer. So they essentially have one person who's in charge of trying to pull together all the data and have kind of and it is hard, from what I understand, to get hold of all that data, even within the company. And so that is maybe also part of it. It's like who owns the data, even within a company, or and the legacy models that have been used. How does it interface with that? I'm very curious.
Yeah,
Is
the
this
legacy
what
models.
Panos and Kyrie, is this what you were also coming to when you discussed this before?
Yeah, I think the legacy models is actually harder than we think, because we could develop an amazing package that shows, we've decreased carbon emissions by X amount while maintaining reliability. Here's an open source Python package. Operators aren't going to be able to integrate an open source Python package with PowerWorld or PSSE or PSCAD or anything that they currently use. So that's a huge lift to implement these technologies. Whereas a lot of the other stuff like, vegetation management or determining upgrades or natural language processing for outage reports, that can be done without fundamentally changing current business as usual.
Yeah,
exactly. I think that was
with Kyrie's points that these were like our main conclusions when we had the same discussion about how this ends up to be. And as Lini also said, the main field of application seems to be applications that have not been easy to do in the first place, and there have not been any specific path or specific methodology to handle them. And AI or machine learning just took that nice spot there, dominated it, and then made it a black box solution. But in operations where there are already standing ways and standing methodologies and protocols, they are very difficult to append them and replace them with whatever might be even, I don't know, infinitely more promising and more efficient, for reasons that maybe have to do as also Marcus said about, and Xin said about, explainability, how we can explain and break down the ideas of AI and ML in a very poignant way that makes sense and does not raise eyebrows or doubts or concerns.
Right. Arun, did you have something to say?
I was just wanting to add to what you just said, Kyrie, is that some of those things where operators are very comfortable doing it themselves, where they really feel that their input into understanding whatever is going on is critical for that infrastructure to exist and function normally. I think those are some of the areas that I also see that it's getting trickier for the AI ML applications to get into. But if there are areas that can complement without breaking down functionality of an operator's day-to-day kinds of stuff, then I think that's where these kinds of AI models are coming in. And from IBM, just an example is there was a piece of work called outage prediction, and how do you manage, for example, the impact of a weather event. Where is it likely to create damages by, let's say, uprooting your poles and wires? What is the result of that impact going to be, and how can you mitigate that to a certain extent by kind of pre-positioning your crews or knowing the extent of damage and trying to mitigate some of those impacts a priori. And I think these are some of the areas where AI ML models are helping grid operators, but perhaps conversely in areas where they feel really comfortable and that their input seems to be extremely more important, then I think those areas might find it probably in just time would say that it may not happen now, but perhaps 5 years from now. But those complementary aspects for improving performance is some of the areas that I am seeing where the latest advances in AI could help these operators.
it's like Becca was saying, it's only a black box until you open it. I like that. So that kind of is the same thing here with explainability, interpretability. It's a black box if you think about it that way, but you can also have it, like Marcus was saying, be translated into some kind of sentences or verbalizations or something that tells you what the algorithm's doing. Panos, did we answer your question sufficiently?
Oh, I'm very happy with what I've heard. I appreciate that we share all the same sentiment. We still have things to handle as we push forward for ideas that we definitely have in much abundance through our works in labs and universities and research consultancy firms. But there are pragmatic concerns we need to address and to convince utilities, operators, and so on. Just let me also mention here the work that I mentioned about interpreting, in this case, neural networks into a more, let's say, straightforward, typical understanding is conducted by Spiros Hadjivasiliadis in DTU, where he's essentially translating the neural network structure of some problem solving and function matching to linear formulations. If you have the time to skim through his recent work, you will see that it is pretty interesting and a nice approach on how we can talk, let's say, the language of the utilities and operators in order to translate our language, which, to us is like kind of mundane every day, but not across the board in this industry.
Yes, thank you. I'm familiar with his work, and that's actually the first time I've heard his last name pronounced. So I might ask you how to do that in the future. I don't want to keep my panelists for too long, so I want to just last call for questions from the audience, if there's any last question. Okay, then I have one last question about final thoughts. So when we look back at this 10 years from now, this is recorded, so we might eventually look back at what we're saying and laugh at ourselves at how naive we were about the spectrum of climate change and AI. But do you have any thoughts about, where do you think this field is going? Is it going to definitely be a hybrid approach where there's always going to be humans interacting with these systems? Are there going to be autonomous communities, autonomous ways of operating infrastructure? And is there anything that we're currently missing that we should be thinking about in this space? And why don't we start with Shin?
Well, I'm still thinking. So I think 10 years down the road, we should be seeing more renewable for sure on the grid. So as all of you may be aware, we're trying to make the grid free of carbon by 2035, and then the entire economy carbon neutral by 2050. So I'm sure in the next 10 years, we'll see more renewable on the grid, and hopefully more IoT devices and AI technology for building control technology and also other spaces. So I think there will be more autonomy in everything while interacting from day to day. But I think to your question, Carrie, I think human will still play a role on many of control, like more safety-related control, which AI may not be mature enough yet. So that's my vision for the future. But let's see if that's going to be accurate.
10 years isn't that long, but at the same time, it's extremely long.
Yes.
Lena, thoughts?
Yeah, hard question. Well, I think it's really exciting. I don't really know what will be. But yeah, I kind of, as I mentioned before, I feel like very kind of happy about this idea that I think the least that I would expect that we are getting from this technology developing is that we will have more of those complementary solutions around. Like there will be more solutions for gathering more data about more things. And hopefully that will, provide some better foundation for decision making. It will put us in a better place to keep the grid operating. When we talk about these questions about load shifting for carbon footprint reduction, maybe we would see. I mean, where that could lead in a lot of different directions if people really got into it, right? So there's a lot of different things that could happen. But yeah, I like this. You know, I hope that we will get a lot more data available somehow. I mean, I hope that we will be able to also give proper credit to people who put in the work in creating those data sets, because I think that is an important part. It takes a lot of work, I know, because we're also trying to do our part of that. Yeah, and so hopefully by having just more data and more information, we will be able to act better. And then, you know, hopefully the other part of it, I mean, I think about like sort of data as kind of, you know, and derivatives of data as one piece, and the other part is, you know, the decisions that you make based on that data. And hopefully we'll also see some use of AI there as well, and improved adoption in industry on that end. So
Yeah, definitely. Thank you. Arun.
That's interesting question, Kyrie. So my feeling is that the explainability nature of the AI work will obviously, I think, get further mature as time goes by. And just like you said at the beginning, that even humans make mistakes, right? So I think this AI models will make mistakes. Humans would make mistakes, but that hopefully we'll all learn from making those mistakes. And therefore, I would think that gradually these AI models will tend to kick in areas that we have not seen before, while human inputs into those areas will probably reduce a little bit. So I don't see a complete disconnection that AI would just take over several things. There will be both of us would continue to work together, but I would definitely see that as the maturity of these explainability of AI models increases, there would be many more autonomous systems, running and driving and making their decisions and moving the field forward. That's my impression of how this field will evolve. And as all of us said here, it's a terribly exciting journey to be in. And I think the community as a whole is striving to make this world a better place. So it's a good time to get involved for people who are not involved in this community. I think that's the way I see it.
Thank you. Last but not least, Marcus, last thoughts.
Yeah, thanks. Yeah, also thank you for the question. Yeah, I mean, my prediction is definitely extrapolating from what I see now, that all the utilities will have a chief data officer or whatever it's called, so some person relevant data. I think even the smaller utilities will at least have some sort of data scientist that's somehow working there. So I'm pretty convinced of that. But yeah, I also think, I mean, there will be applications of machine learning all across the different power sector problems, but also in the climate-related problems, like in transport, in industry, everywhere. I think there will be certain applications, but it will never be AI alone that drives the change, right? I mean, there need to be a lot of policies in place, other actions in place. I mean, we can decarbonize the system without AI, but we cannot just with AI decarbonize the system. I mean, we need solar panels, renewables, and whatever first, and then we can maybe use AI to improve a little bit. And so that's why I think, but there will be really great applications. I'm pretty certain about that. And maybe just because you said more people should be involved, just a blatant advertisement, of course, if more students ask you, send them, of course, the link to Climate Change AI. I mean, they have a great newsletter, or we have a great newsletter. We have great resources on our homepage that get students interested. I mean, the newsletter has job offers and everything. So please send them to our resources, and also give them maybe my contact if you like. I can also point them to resources. So just blatant advertisement here.
Oh, thank you. That's helpful. And that's also part of the session, by the way. If any of you audience members liked what you heard, maybe you want to partner with one of us or start a collaboration, or you have you're a utility, you want to host a demonstration of AI, or you want to learn more, please feel free to contact me or any of the panelists here to have that conversation. And thank you all so much for coming, attendees, panelists, speakers. I'm looking forward to the next step with the Grand Challenge, and I hope you are too. And I hope you all have a great rest of your week. And a special thanks to Marcus and Arun for joining at such strange hours. I really appreciate your time.
Thank you, everybody.
Thanks.
Thank
Bye.
you so much.
Thank you. Bye.